Hi students, welcome back. This is plus 1 computer science and computer application chapter 2 part 10 video. Before getting into the video, please do subscribe. In the previous class you have learned binary addition and now you are going to learn binary subtraction. So let's start binary subtraction. We know that binary number system consists of two digits, that is 0 and 1. So the calculation will be done for the combination of these two numbers. For example, what is 0 minus 0? We all know that 0 minus 0 is 0. And 1 minus 0, obviously the answer is 1. And the next combination is 1 minus 1. The result is 0. So combination goes like this. We know that 0 minus 0 is 0. So what will be 0 minus 1? What will be the result of 0 minus 1? Is that possible? So let us try with an example. Let us take two binary numbers 1 0 1 0 minus 1 0 1. So let us do the subtraction. So when subtracting 1 from 0, we have to borrow 1 from the most significant bit, nearest most significant bit. So let us do it. We do have 1 here, strike out that 1 and replace with 0. And write 1 bit to the least significant bit. Now it is 1 0. What is 1 0? 1 0 in binary is equal to 2 in decimal number. So 1 0 means 2. 2 minus 1 is, the result will be 1. So we have to read it as 1 0. Next one is 0 minus 0. We know it is 0. 0 minus 1, again it is not possible. Borrow from the most significant bit. Replace it with 0 and write 1 here. You have to read it as 1 0, which means 2. 2 minus 1 is 1. So this is how you have to do the subtraction. Borrow 1 from most significant bit and replace it with 0. This is the technique used in binary subtraction. So for example, perform binary subtraction for the following. We have three different problems. First one is binary number. You have to identify the numbers by its base. Here binary numbers are given. Second one is two decimal number for subtraction. And the third one is two negative numbers for subtraction. So let us try. So the solution for the first one, the binary number 11010 minus 101. You have to do subtraction for these two binary numbers. So first we have to do 0 minus 1, which is not possible. You have to borrow 1 from the nearest bit. Strike out this 1 and replace it with 0. And write the 1 to the least significant bit. It is 1 0. 1 0 means 2. 2 minus 1 is 1. And next is 0 minus 0, which is 0. And again we do have 0 minus 1, not possible. You have to borrow from the nearest bit. Strike out that 1 and replace it with 0 and write the 1 to this bit. So here it turns 1 0. 1 0 minus 1 is 1. And 0 comes as it is. Then last is 1. So we got the result. Answer is 10101 base 2. So this is the way to subtract binary numbers. And the next model, we do get two decimal numbers. We have to find the binary and then we have to subtract both the numbers. So binary equivalent for 10 is 1010 base 2. Hope you remember the method 10 divided by 2, repeated division by 2. This method you have to do to find the result, binary equivalent of 10. And then the binary equivalent for decimal number 3 is 1 1 base 2. So this is the binary equivalent. Now subtract both the numbers. So first step, 0 minus 1, which is not possible. You have to borrow 1 from the nearest significant bit. So 1 0, 1 0 minus 1. 1 0 minus 1 means actually it is 2 minus 1. 1 0 in binary is equal to 2 in decimal. So 2 minus 1 is 1. 0 minus 1 again it is not possible. The nearest significant bit is also 0, not possible to borrow. So move on to the most significant bit, it is 1. Strike out that 1 and replace it with 0 and give 1 to the next bit. So it is 1 0 which means 2. So now it is 1 0 which means 2. From 2 we have to give 1 to the next bit. So 1 0 minus 1 is 1. 1 0 we have to strike out and we have to write 1 there. Now here it turns as 1 0. So 1 0 minus 1 is 1. And then we do have the remaining numbers 1 and then 0. So it is base 2. So 10 minus 3, when you do the subtraction for decimal, it is positive 7. So positive 7, the binary equivalent is 111 base 2. So final answer is 111 base 2. And the third pattern, you do get two negative numbers for subtraction. What we have to do? As usual, find the binary equivalent of both the decimal number. And then you have to find 1's complement and 2's complement to make it negative number. So let's start. Binary equivalent for 4 is 100 base 2. Binary equivalent for 7 is 111 base 2. So these are positive values. Now we want to find negative value. For that, 1's complement and 2's complement you have to find. First step, you have to make this as 8-bit format. Here we do have 3 bits, so add 5 zeros in front and then write 100. And the second step is 1's complement. Take inverse of all the bits. And the third step is 2's complement. Add 1 to the least significant bit. So 1 plus 1 is 1 0. 0 as some bit, 1 as carry, 1 plus 1, 1 0, 1 as carry. So 0 plus 1 is 1 and remaining all the ones you have to write as it is. So this is the value for minus 4 base 10. Similarly, you have to do for 7. So finally we got binary equivalent of both negative numbers. Now we have to subtract these numbers. So first minus 4 base 10. The binary equivalent of this is 6, 1 and 2 zeros. And then you have to write minus 7 base 10. The binary equivalent for minus 7 is 5, 1, 2 0 and 1. Now you have to subtract both these numbers. 0 minus 1 is not possible. You have to borrow 1 from significant bit and that bit is also 0. So move on to the next bit. Now strike out this 1 and replace it with 0. Add 1 here. It is 1 0. So strike out this 1 0, write 1 and borrow 1 to the least significant bit. So 1 0 minus 1 is 1. And 1 minus 0 is 1. 0 minus 0 is 0. And 1 minus 1 for remaining all the bit it is 1 minus 1, which means the result is 0. And the final answer is 1 base 2. So look at the binary number, it is a positive number. When you subtract minus 4 minus 7, it is actually plus 3. So let's see how to do subtraction for two negative numbers. Minus 4 minus 7. So when you get this type of questions, you can simply remove the bracket and you can simplify this. Minus 4 plus 7. Minus of minus will turn to plus. So rearrange this. 7 minus 4, it is equal to 3. And do only the binary calculation. If you're confused with the decimal calculation, simply ignore the decimal numbers and write only the binary values. And this part, this simplification is used for binary addition. After the simplification, you can do binary addition. You have to find 1's complement and 2's complement only for minus 4. And find binary equivalent for 7 and do binary addition. If they ask you to perform binary subtraction, you have to perform binary subtraction, or else if they ask you to perform binary arithmetic, this type of questions you can simply simplify the question and you can do binary addition or you can do binary subtraction. Okay children, we have completed binary subtraction. Now you can perform the following binary computation. Here they didn't mention whether it is binary addition or binary subtraction. In such cases you can do binary addition wherever needed or you can do binary subtraction. So here you have to subtract both the number. At the same time this is also subtraction, and here look at this sum. When you open this bracket, minus and minus will turn into plus. Minus of minus will become plus. So in this case you can do binary addition. For minus 2 you have to find 1's and 2's complement, and then you can find the binary equivalent of 6 and you can do addition. It is up to you. If you want you can do addition or you can perform 1's and 2's complement for both the number and you can do subtraction. And finally you have one binary number for subtraction. So complete all these problems. Thank you.